Section 7.4 is all about finding the area of a triangle. So we have two objectives for this section. First is to find the area of side angle side triangles, and second is to find the area of side triangles. Now, we solved these triangles using the cosine laws. Now we want to focus on finding the area. So the area of a triangle is 1/2 base times height, right? Where b is the base and h is the altitude drawn to that base by a vertical line such that it creates a 90-degree angle. We probably learned this back in like middle school, if not elementary school, right? My question is, but what do we do if the height is unknown? Well, if the height is unknown, we can rewrite h in terms of sine. I know sine of c is opposite over hypotenuse. Well, that opposite angle to C is h. So sine of C is h over our hypotenuse, which for this triangle would be a. And if I multiply both sides by a, I find that a sine of C equals h. So now I can substitute that. I have that k equals 1/2 a b, because I like to write my variables in alphabetical order, sine of c. So this gives us our three new equations for finding the area of a triangle, depending upon which inner angle is known. So we have k, which is our area, is 1/2 AB sine C. K is 1/2 BC sine A, because A is the included angle between B and C. And K is 1/2 AC sine B, because B is the included angle between A and C. This is how we solve side angle side triangles. So let's work through an example. So first thing we're going to do is find the area of a side angle side triangle. If I have A is 5, B is 3, and C is 50 degrees, let's find the area of a side angle side triangle. Well, C is 50 degrees, and I know A is 5 and B is 3. So I have K is 1/2 AB sine of C. K is 1/2 5 times 3 sine of 50 degrees. Make sure your calculator is set in degrees and not radians, and you'll get about 5.7 square units. And I don't know how big these triangles were. Like, was it like 5 miles, 5 inches? So we're just going to say square units. So that's where we find the area of a side angle side triangle. Now, to find the area of side triangles, we need to use a different formula. And we're going to use Heron's formula. So in this case, if I have the area K, that's found by first finding our S, which is 1/2 the sum of all the lengths of the triangle. And then we take the square root of S times S minus each individual side of the triangle. Now, let's go off on a little bit of a tangent. So Heron's formula is attributed to Hero of Alexandria. And he was a Greek engineer and mathematician from 10 to 70 AD. Among other things, he developed, and I showed a video of this in class, this is called an eolipile. Let's say that again. Eolipile, right? And it was the first known steam engine, but they didn't realize it was a steam engine at the time. It was just kind of treated like a toy. So what does an aeolipile look like? So here's an aeolipile, right? We have water in a kettle that's getting pushed, that's getting pushed by steam, it's getting heated, and then the steam goes into this ball and it spins around really, really fast as the water gets higher and higher, hotter and hotter. But they thought this was a toy. So this is an aeolipile. Let's go ahead and solve a triangle using Heron's formula. The first thing we need to find is S, which is 1/2 the sum of the sides. So S in this case is 1/2 5 plus 6 plus 9. Well, 5 and 6 is 11, plus 9 is 20. So I have 1/2 times 20, which is 10. Now I have k, and k is our s, times s minus each length of the three sides of the triangle. So I have k is the square root of 10 times 10 minus 5 times 10 minus 6 times 10 minus 9. So k is the square root of 10 times 5 times 4 times 1. 10 times 5 is 50, times 4 is 200, times 1 is still 200. And we want to simplify this radical. I could plug it into my calculator right now, but let's go ahead and simplify. That's going to give me equals the square root of 10 square root of 2, which if you plug into your calculator is about 0.14 square units.